Hey guys, and welcome back to Box Mining. Today we have a very esteemed guest, Dawn San. She's the professor at Berkeley and also the recipient of the MacArthur Fellowship, which is one of the most esteemed prizes in computer science or fellowships in computer science. And today she's sharing a lot of insight about what's happening in the blockchain space and talking a little bit about something that we don't cover too much on this channel, which is privacy on blockchain. So Dawn, welcome to this channel. Hope you're doing well.
Great. Yeah, thanks all for having me.
So I think it's your first time on a channel, and I just wanted to get my audience quite familiar with you. So can you just tell a little bit about, kind of your story and how you got into the blockchain space?
Yeah, that's a very good question. So I have been working in security and privacy for a really long time. I think more than two decades now. And right. Actually, it's interesting. I think one of my earlier papers actually was on proof of retrievability. And actually, Juan Bennett, I invited him to give a guest lecture in my blockchain class earlier, and then he actually talked about my paper, how that helped inspired some of the design in the Filecoin protocol as well. So I think actually that was one of the earliest papers in this proof of retrievability. And so that's just an example showing that when you look at blockchain, really the key is, security is a core part of blockchain. So in some sense, I actually have been working in the space for a very long time. And then essentially in terms of the fundamental technologies. And also it's interesting, I also have been doing work in AI and machine learning, and then I as blockchain continues to develop, that was I think I taught some blockchain classes in 2018 time frame. And so on, and really, I think as many of us here, we do think that blockchain is here to stay, and the blockchain is going to change the world. But it has a very interesting path. The more I work in the space, the more I think you come to understand the path and so on. So that's, and in my research lab, we have been developing cutting-edge technologies in security, privacy, and blockchain. And at the time, essentially, I was seeing the challenges, for example, Ethereum was facing, and so on, and really for blockchain to change the world, to have real world impact, to really, fulfill the vision that we have for blockchain, really needs better fundamental technology in the space. So that's essentially what drove me to blockchain. Like, I see machine learning AI is one really important advancement for the world, and that mainly just help us to build more intelligent systems. But for blockchain, it's interesting. It has a more potentially have deeper impact in terms of the structure in our society, and essentially the relationship between individuals and relationships between individuals and institutions and other entities. So it's a very different type of disruptive innovation, and yeah. So I, given the vision I see and also the needs I see in the space.
Very deep. That's very interesting. I think that's a very interesting angle as well, because I think there's very few people who can say, one of my initial publications directly led to a lot of this innovation here. So definitely that's a very cool angle to come from, because you've been in the, space, the research space and the computer science space for such a long time, that you see all this innovation come and you're seeing, okay, what does it need, right? I think that's a very interesting angle. Like you have the idea of what it needs. And I think I want to push to that as well. I mean, you see Ethereum right now, and you're talking a little bit about privacy. What drove you to that angle?
I see. Okay, so for example, Ethereum and most of today's blockchain platforms, really everything is in the public. So when you have that, of course, you can say you have the transparency. You can go check whether something, everything is correct and so on. So it has some advantages. But on the other hand, that significantly limits the use cases, right? Because ultimately, in this world, everybody I think has their private information, either it's users, individuals, or entities like financial institutions and so on. Being able to protect your sensitive information is really important. And as we build up the blockchain platform, I think improving scalability is one thing, and also having better privacy protection. That's really important. That's going to help us to expand and enable more use cases.
That's actually very interesting because, like, right now, I think we're using one of the transparency aspects of blockchain. I mean, with the rise of decentralized finance, we can see where our funds go, which is great, right? Now you can start tracking where the funds go. It might be very complicated to see, like, with all this yield farming or DeFi yield aggregators, but at least you know where the funds are. You can trace it, track it on the blockchain. But you're talking about something that's also quite different here, which is not everything needs to be private, right? And I think this is one of the unique aspects that drove me to look into Oasis, because at the same time, you want to keep some of the information. If it's sensitive company information, like, for example, where funds are stored for a particular institution, they don't want that information to be revealed publicly, right? So where does this come into play? Like, how does this kind of all work out? Where do you see kind of this fitting in? Do you think that everything on Oasis private? Is everything on it public? How does this all fit together?
And also, I want to add to it, guys. Like, on one hand, transparency is helpful, so you can see exactly what's happening. But on the other hand, you have to keep in mind that everybody can see that information, and then there's a lot of like attackers out there, bad actors. When you have that information, they can utilize that information for harm as well. So that's why, for example, there are these front-running attacks and there are back-running attacks. There are various attacks that people can launch, and for big parts, it's because information is out there, so they can see everything, and hence, when they see your information, they potentially may be able to leverage that and mount attack on you. So that's why, right, everybody needs to protect their sensitive information. That's you need that to protect yourself.
That's actually very true. You brought up the front running attack, and I just explained this to people because, like, I think a lot of people when they're buying on Uniswap, the moment that you start executing an order, it becomes public because now it's sent to the blockchain, but the blockchain hasn't processed that yet. So something that was very interesting, I just wanted to add to this here, is that there are people who are specifically designing bots to see where large orders are going and then to exactly front run them. So then they can get the order. So like, say if someone wants to buy 500,000 worth of X token, let's say call it bunny token or whatnot. But if that is the case, if someone sees that and this is sent on the blockchain and someone can scan that, then a bot can also execute the same order before them. And then they can get the advantage because they know the price is going up. So they can buy some beforehand. Price gets pushed up and now they can profit off that. And there's a lot of bots for that. And that's one of the issues of being fully transparent all the time, where there's now issues of front running. There's also issues of data breach. So then, okay, can you talk to me about how you're solving that then?
Right, exactly. So actually, even last year, on our Oasis platform, we have developed this, we call like, for example, private Uniswap. In this case, essentially your order will be encrypted when it's sent to the smart contract. We enable this confidential smart contract. So then exactly like you explained, then the attackers won't be able to see your order before it's executed. So there's no front-running attack. And so this Uniswap smart contract just runs in this secure execution environment as a confidential smart contract. So then you have privacy protection and you don't have these front-running attacks because the attacker cannot see your order.
So this is actually very interesting because this is not just protecting privacy for the address, but it's also protecting the information that's being processed.
Exactly.
I think that's a very big difference here because obviously, I think my audience, we as a community, we know about privacy coins, right? We know about Monero that tries to hide the address or kind of obscure where transactions are going. But at the same time, it's not just about the address, but now you're protecting the information, the smart contract. So you're encrypting that data so people can't read, oh, look, I want to buy $500,000 of bunny tokens. It will just be garbled to them. But the blockchain on the other side, the smart contract itself understands that. So then it can execute the order as per instructed.
Right. And the Oasis platform is a unique platform to support this. You asked earlier, how we do this and so on. So the Oasis platform has a very unique architecture that we call this Paratime architecture. So this architecture actually naturally enables all these different advantages, including actually scalability as well. I can explain.
Yeah, sure. Explain a bit more detail. So how does that work then?
Right. Exactly. So the way to think about it is, so with Ethereum and most of the blockchains out there, so they have the scalability issues. Actually, there's a main reason for that. So when you look at the blockchain, usually there are three key functions that need to be performed: consensus, how different nodes reach consensus, and compute to execute smart contracts, and storage to store the states of the smart contracts, accounts, and so on. So for example, in Ethereum, all these three functions are bundled together. So each node has to do all three functions. And hence, this can actually naturally lead to these bottlenecks and so on. Because also each node has to do the same thing and so on. So in our case, then in Oasis, the architecture, we have a novel modular architecture. We actually decouple these functions. We separate the execution from consensus. So what it means is that we actually have two main layers. We have the consensus layer. The consensus layer, it will run proof of stake. So the nodes just do consensus. And then on top, we have what we call Paratime layer. So Paratime stands for parallel runtime. So it's short for parallel runtime. So what it means is that we actually have this natural parallel execution architecture. So in the Paratime layer, we can have many paratimes running at the same time. Each paratime is run by a paratime committee, and this committee can be dynamically selected in a pool of compute nodes, and so on. So in all the nodes that participate in the network, for example, and then each paratime can have its own paratime engine, which is essentially like a smart contract VM. And this also naturally enables us to actually concurrently support different types of smart contracts virtual machines. So for example, we are fully backwards compatible with EVMs, so we can support Solidity smart contracts very easily. You can just, and all the Ethereum developer tooling all works for that. And it's really easy to have a Ethereum Solidity smart contract to just run on our platform. And so that's with a Paratime committee that runs this Paratime, this EVM Paratime engine. That's how it works.
That's actually quite crazy. So I just kind of wanted to interrupt you there because, just to put everything in perspective, because development is actually quite time intensive, and we're just beginning to figure out how Ethereum kind of development can be improved, because obviously you've seen numerous hacks on Ethereum in the past, and developers now are just trying to get the code better. So I think I took a lot of knowledge in just now. So a few things that I kind of understood is you decoupled the consensus from also the execution, which is very, very interesting. So now you have the ability to not only scale, but you can also support multiple environments as well, which is super interesting. So one of those environments being Ethereum, so now you can be compatible with Ethereum and the EVM.
Another one can be, you can develop, we support smart contract language using Rust, so you can actually write smart contracts in Rust, which it's a mainstream programming language, a lot of developers really love. It's a beautiful language. And also then going back to secure computing, so we support, so one of the Paratime committees, for example, the nodes can run secure hardware, and then we can support confidential smart contracts using secure hardware. You can have right. So naturally, then you can support all these different concurrent and parallel runtimes, paratimes that we call, and it gives you natural, better parallelization and also extensibility and flexibility, and also actually naturally supports a seamless combination of permissioned and permissionless use cases.
That's
Because
insane. That's a huge amount of knowledge dump here. But I think it's absolutely insane. The implications of this is absolutely crazy because like a few questions just pop off the hat. So you said, okay, look, this can support Ethereum. So now can you make a bridge to Ethereum as well in that case, like bridge assets between with Ethereum because it's closer?
Exactly, absolutely.
And can developers also port code over? So I think one of my concerns is, let's say there's a amazing app that's been on Ethereum. Let's say it's Uniswap or someone, and it's open source. Can they just port code over to Oasis, or is there any risk as well? Is the EVM environment exactly the same, or would there be slight differences as well in the kind of the execution environment?
Right. So we support actually different versions of the EVMs, like different teams have been developing different EVM engines, and it's very easy to run them because you can just have different Paratime to support that, have different Paratime committees to run them. So yes, we and today it's basically most of the Solidity smart contract on Ethereum, they just run in this environment with no changes needed.
Okay, so that's very interesting. So they can directly port their applications over with very minimal changes and then start running that on Oasis. Something that's actually quite interesting is because you can support different runtimes, does that mean there will be compatibility issues as well? Let's say if one decentralized application on Oasis is really popular, and then it wants to interact with another application. Let's say you have Uniswap, you're doing some tokens, and now can those tokens be ported over to another runtime, or is there a limitation there?
Right. So these different runtimes are different paratimes. They can communicate through sending messages, sending transactions to each other, and so on. So then there's no issue with the compatibility, like because they don't need to all run in the same runtime or same paratime. So essentially, one way to think about it is that these different paratime environments, you can think of them as like different sub networks that each one essentially can fully have its own flexibility. Like I said, they can choose its own Paratime engine. It can have its own criteria, what kind of nodes it wants to participate. So for example, for some applications, maybe they only want nodes in certain geographic regions, or like I said, for some, if you want to support confidential smart contracts, maybe then you want to have nodes that have secure hardware capabilities. And also for some use cases, like I said, they may be a permission use case where a certain enterprise, they just want to have nodes, like a few enterprise together, they just want to have themselves maintaining the nodes and so on. But so in that case, it will be a permission setting. But the whole architecture, because all the different paratimes, they share the same consensus layer, so their states basically are synced in the sense that each paratime's state, the root hashes get synced to the consensus layer. So then this allows all these different paratimes to communicate with each other, and also at the same time, they essentially they share the same strong security for consensus from the consensus layer, and also allow them to share the same the ledger. To make it easier for them to communicate with each other as well.
That's actually very, very interesting. I think it's very different from everything that I've seen so far.
And also what's even better is that actually the scalability actually is better. So for example, the way you have to actually tie this paratime layer to the consensus layer, because otherwise in the consensus layer is doing consensus, how do you know whether this paratime, the state is correct, and so on. So we have a way to tie the paratime layer to the consensus layer through what we call discrepancy detection. So the idea is that, let's say you have this paratime committee that runs a paratime engine and basically executes the smart contracts in that environment. And then, so this committee, through this discrepancy detection, what it means is as long as one node is honest, is doing the right thing, then the consensus layer basically can detect any misbehavior from this paratime committee. And hence, you get extremely high security, actually, for a much lower replication factor, which means that to achieve the same security level with the sharding approach, you actually would require higher replication factor than using this verifiable computing discrepancy detection approach. And hence, with our approach from the parallelization and scalability, we can actually be much more efficient than sharding, than parachain, and so on with this new architecture.
That's actually very, very interesting. So it's a completely different architecture and design from what we've seen and the other proposed solutions as well. So on this channel, we talked a lot about sharding. We talked about to the guys from Elrond, they talked about full state sharding. We also talked about Ethereum 2.0, which is going to implement a sharding architecture. So this is kind of just filling in everything. So Don's like, this is like better. And this is also quite interesting because we also explore Polkadot a little bit, and they're always talking a little bit about using parachains to scale the network. So this is something that's completely different, but at the same time, it has both scalability, privacy in mind. So that's what's kind of interesting about Oasis. So it's like I'm just kind of trying to put fitting everything into place. So I think this is very cool. I have a question though. So you talked about from an architecture perspective, right? So if you think about Ethereum, everything executes on the same time, and this is why we're getting the bottlenecks because there's just too many transactions. We can't. The processing power is always the same, right? So that's not good. But on Oasis, obviously, you can split it off and have different, kind of what was it called again? Sorry, it was time.
Different Paratime.
Paratime. Yeah, that was the name I was looking for. So Paratimes that can do this. But one of the issues here is that if you have a different Paratime, you're talking about syncing this discrepancy. What if this Paratime decides to be dishonest? I mean, the thing is, there's a lot of motivation to do so, right? Right now, we have financial contracts worth millions of dollars. So there's a huge incentive for them to be, or maybe attempt to be dishonest. How does this discrepancy syncing system work? How do you prevent value from being lost in there?
Right. Yeah, exactly. A very good question. So the idea here is that, again, we have this Paratime committee, and the Paratime committee can be dynamically chosen from a pool of compute nodes, and each node has to stake in order to join the network to be a compute node. Mm-hmm. And then as they are selected to run this Paratime to do this transaction for the smart contract execution and so on, then so essentially that's what I meant by the replication factor, is that in this Paratime committee, every node is doing the same work, or they are supposed to be doing the same work. And then from the consensus layer, what the consensus layer will check is for each node with their compute results, they will be going to the consensus layer. The consensus layer will be checking or do something what we call discrepancy detection. Essentially, it's verifiable computing, right? So the consensus layer wants to make sure that the execution has been correct. And one way to do it is what we call discrepancy detection. So for example, let's say you have 100 nodes in this Paratime committee, and each node is supposed to be executing the same set of transactions, smart contract execution, and then they will be submitting results to the consensus layer. The consensus layer will be checking whether these results are the same. So in this case, as long as you have one honest node who has been doing the correct work, then any node that's trying to behave, that means it will introduce a discrepancy, meaning the reported results there will be discrepancy among the reported states.
That makes sense, yeah.
By the different nodes. And hence, then the consensus layer will know that there's something wrong. And then once this happens, we have another process called dispute resolution. So then basically that means the consensus layer has discovered someone is misbehaving. Then you need to figure out who is misbehaving using the dispute resolution methods. So that's a little bit more involved process. But in general, like for example, a simple way is you can have a bigger committee and then you rerun this and you see what the result is and so on. So there are different ways to do it. And so once you then you figure out who actually submitted the wrong results, then you slash them. Basically, they get right. So in this case, then you have incentives to behave correctly, and also as long as you have one node that's behaving correctly, then you can detect any misbehavior, and hence it actually has very, very high security. And also because you can detect any misbehavior as long as you have one honest node, So that's why it reduces our replication factor for the same security level. So for the same security level, we need a smaller number of nodes in the committee to actually achieve that security level.
That's actually very powerful. So it's unlike Byzantine fault tolerance, which requires 51% to be honest. You only need one honest node within that committee to make sure to ensure that this calculation is done correctly. So that's actually really, really powerful there. Mm-hmm.
Right, exactly. So for other models, usually you need 3F plus 1 or 2F plus 1, where F is the dishonest, number of dishonest nodes. Whereas in our case, you only need F plus 1 nodes.
Got it. That's really powerful.
And that is why it's more efficient than other methods.
Got it. That's actually really, so we went really, really deep into blockchain architecture design there. I hope you guys got a little bit of insight, but it's actually very, very different from everything else. And I really appreciate Don's perspective here about everything that's going on. I think it's good time to actually zoom out as well and just talk a little bit about the application side of things. So we went deep into blockchain. We understand a little bit more about the architecture, but okay, now that we know this, how can this be applied? How does this kind of work? Where do you see this being applied in the future? Where's your vision for this going?
Yeah, no, that's great. So for us, essentially, we say that so Oasis, what is the Oasis network? It's the first privacy-enabled blockchain platform for open finance and a responsible data economy. So what that means is, so given its unique architecture and technological advancement, with the enablement of both scalability and privacy protection, it can really enable new use cases, new paradigms. So for example, DeFi is really hot today. People talk a lot about DeFi and so on. But in DeFi, we're seeing, I think, two challenges. One is scalability challenges, and the other one is the privacy challenges that we discussed at the beginning, like including attacks like front running and so on. Mm-hmm. So then what Oasis network, our Oasis platform can provide is what we call scalable and private DeFi. So we can provide better, greater scalability for DeFi. Again, given that Ethereum is we are backwards compatible with the EVM, and so it's actually really easy to migrate the Solidity smart contracts. And also, we are in the process of building a bridge. Hopefully, it will be done in the near future.
So what does this bridge do? So you can port tokens over via the bridge?
Right. So basically, for example, on Ethereum, you have various assets, either it's ERC20 tokens or whatever. You have various assets, and then this bridge would enable you to, for example, equivalently, for example, creating wrapped assets here. Like, so you lock the assets over there in Ethereum, and you bring the assets here. You create these wrapped assets, and then essentially you can basically bring assets over, and then you can run these yield farming or these DeFi applications on the platform, but with much lower costs. It's not like you don't have to pay like $50, $60 for doing a transaction or something, and so you can do it in a much more efficient and fast, scalable, and cheaper way.
Got it.
So that's a
right. So just to summarize, so you can actually, so that's actually quite a powerful proposition. So you can bridge assets over, which is great. So that means you can start trading with having your own version of a decentralized exchange on Oasis. But also because Oasis is compatible with Ethereum virtual machines, so it's compatible with EVM, you can start developers can just start directly porting over to Oasis. And also that's something that's quite interesting is because Oasis supports different languages like Rust, and you can actually have other bridging links to other Rust-based blockchains, right? Is that easier as well for them, and to also have applications that can port over from, say, like Elrond. I think Elrond is Rust-based, so that means that developers can kind of port over code from both sides, right?
Right. Yes. And then, so scalability is one thing, and then also with the privacy protection, we can enable what we call private DeFi. So, for example, as I mentioned, we've developed the private Uniswap and the private compound. So a lot of these applications, essentially, you can have the private version, the privacy preserving version that can help address many of the challenges that we see in DeFi today, like the front running and so on. And also, like I think for institutional, for institutions, again, this type of privacy is even more important for them. And I think in the current form, it's difficult for them to participate with better privacy protection. It can essentially expand the user base, and we can actually bring even more the mainstream users into the space.
That's actually very interesting. I think we've been through stuff like voting issues where, voting, what people want to do voting on the blockchain, but then everything became transparent. And I'm like, why would you ever want to do voting on a blockchain? But now with privacy, it's much less of an issue. So I think this is actually very interesting going forward. So I think that's where I feel like, I think this conversation was great because we talked a lot about not just the architecture, but also about the future vision of this. So in terms of Oasis, what kind of developments do you have in mind right now? Who's committed to develop on Oasis, and what are they doing?
Right. Yeah, that's a great question. So in DeFi, we actually have a number of partnerships. We also just announced a partnership with Chainlink recently. They will be bringing Oracle services to our platform, and we have a number of other DeFi partnerships who are all building and providing various core DeFi components on the platform to help build up the DeFi ecosystem. And also, so the scalable and private DeFi is actually just one type of use cases the Oasis platform can enable. And actually, there's even bigger use case that we call a responsible data economy. It's essentially through data tokenization, because we enable privacy, we combine blockchain, the ledger capability, and secure computing together. So we enable this truly new thing that we call data tokenization. As so far, we mainly talk about financial assets, these tokens representing financial assets. But we also know, data. People say data is the new oil. So data is it's actually the key driver for modern economy, and it's also, of course, most of the data is actually very sensitive, but it's also hugely valuable. And so we all know that there has been actually a lot of tension between, I think, how to protect users' privacy better, and also, I think, for example, for companies, how to actually enable this data to be utilized and so on. So essentially, we want to have a responsible way of utilizing the data and extract value out of the data. And more importantly, I think, especially for users' data, what you want is that you want to be able to protect your rights to the data, and also at the same time to be able to use the data in a privacy-preserving way so that users can benefit. So what the Oasis platform can enable is, for the first time, it can enable the creation of this new type of assets that we call data assets. So essentially, users can, and for users' own data, the user can, the platform allows the user to, we call tokenize the data. So the blockchain can essentially provide an immutable log of users' rights to data, and also how user wants the data to be utilized. And then with the combination of the secure computing, then we can allow a third party to utilize the data while protecting users' privacy. And we actually have seen a number of really exciting applications on this. So one application that will be launching soon in partnership with the Genomic company is right in the space of helping users to become owners of their genomic data. As we all know, genomic data is really sensitive, and also it's the data that you cannot change. You cannot change your genes.
Yes.
Right. So right. So you may have heard about some like 23andMe, and so there are these direct consumer genomic companies. They actually have cited a slowdown in their consumer adoption due to consumers' concerns for privacy, how their genomic data may be handled. So with the Oasis platform, actually, users have control of their genomic data. Users can decide how they want their data to be utilized. The data will be stored in encrypted form, but users can specify who and how the data can be used. For example, in this case, the user can give consent to the genomic company, and then the genomic company can to provide the genomic data analysis. And then with our platform, the genomic company can run the genomic analysis in this secure computing environment. And then so users' data is being protected, and at the same time, the user can benefit from the analysis results. So this is another example of how this platform can enable this new form of data assets. And also we have we just announced our partnership with Binance to build up an alliance called the Crypto Safe Alliance to help bring different exchanges together to fight crypto fraud, because there's a lot of frauds at these exchange bad actors that the exchanges need to identify and prevent these crypto frauds. So with platforms like this, it can help different entities, even if they may be mutually distrusted, they can actually securely share information together to do computes over the information where each entity wouldn't know information about others, and together perform a computation, and in this case, for example, fight these crypto fraud.
That's actually very interesting. I think a lot of this stuff is forward thinking, and I think it takes a bit of wrapping our head around, right? And I think this is the insight I really got from talking to you is, thinking for the future. I mean, at the end of the day, Facebook got a lot of, this is very public, Facebook, they leaked sensitive information. And in fact, they built their entire business on being able to obtain sensitive information about our lives, right? That's kind of the crazy part of the Facebook business model is they monetize people's data. That's how the company works, and it's a billion-dollar industry. On top of that, you were talking also about data collection when it comes to our genes, and I've done 23andMe, so I know I'm like whatever, like I think it's like 92% Chinese and then like 8% others, and I was like super interesting tracing where my genes are. But kind of surprising was the last time I talked about this data privacy thing was that I started to realize that whilst I paid I think it was like $199 for the test. The company doesn't monetize that, right? The company 23andMe, most of their money is made by selling my data. So I didn't realize that data could be worth like $1,000 or $5,000 to various companies doing research, right? So this is actually kind of crazy. I completely did not realize it at the time, but after talking with researchers in the space, I started realizing, oh crap, if I'm part of a select group of people, there's companies that are willing to pay a lot of money for that data. And first of all, I just agreed to it. I didn't know it was worth money. And second of all, why don't I get any of that money, right? So I think this is something that's kind of interesting for a lot of people who don't know the perspective of this is that all of a sudden our data is worth money. Companies are paying for it. And really, this is something that's forward thinking about how to protect people that provide data. I provided my genomics data for free, but at the same time, how to give that control to people. Like I'm sure there's going to be regulation in this in the future and how to make the compute happen. But I think something that's kind of interesting, just going back to the genomics idea. So would you store the entire genome? Or I guess 23andMe, they look at particular sections, right, of our genome data. So how would you store that information once it's obtained? Because that's so much data that, can Oasis even handle that, like an entire or sections of someone's genome?
So this is also why our platform architecture uniquely supports this, right? So for example, you will never be able to store this data on chain, on the consensus layer, the ledger itself. So that's why by separating execution from consensus, it really helps. It provides much more flexibility. So the actual genomic data is now stored on the consensus layer, the ledger itself. What you store there is essentially, for example, hashes of the data, and so on. And then the actual storage is actually quite flexible. Of course, it will be stored in encrypted form, but it can be stored in our Paratime environment. And also in certain cases, users can even host the storage themselves as long as they provide the availability when the data needs to be utilized and so on. So actually really enables much better decentralization and distributed system.
Interesting. That's actually a very cool discussion. I think we definitely want to explore this in the future as well, because there's so many applications of this. I'm glad that you're using that data also to help fraud with Binance. And if people want to know a little bit more about the project, how would they go about learning more about Oasis?
Okay, yeah, so people can visit the website. It's Oasis Protocol, .org. It's for the Oasis Foundation, and also Oasis Labs provides a lot of these privacy technologies as well. And actually, with the data thing, one more thing maybe I can just add very quickly is people do like yield farming these days. So actually, with the data tokenization, with yield farming, liquidity farming, you put down liquidity, you contribute liquidity. So actually, interesting. Similarly, with this data tokenization and data economy, you can get the data yield. You can stake your data, and then if others, then you can create a pool, and we call it a data trust. And as others utilize the data and then pay fees into this data trust, people who stake their data in the data trust can also get data yield. Which is
that's actually pretty cool. I didn't think about it. So I can stake my genomic data. People can't read it, obviously, but they can extract data from it. That's kind of cool. So now I can be paid. I can stake my data everywhere. That's actually a very interesting model. I didn't think about that, but that's actually super cool.
Yeah, a lot of really exciting use cases and so on. Oh, and also people can follow us on Twitter.
Awesome. So I think, Don, thank you so much for sharing your insights. I think I'm actually quite inspired for the future for where this can all lead. And I feel like putting everything into perspective, when Bitcoin first started, people were like, oh, this is just a very slow database. People were just like, whoosh. But now as the whole blockchain space has been improved, and we're solving issues with both scalability and privacy. And I think that's kind of really awesome to be in this space at this time. So I'm sure there's a better descriptive word out there other than awesome, but right now that's kind of what I'm feeling. So guys, I thank you so much, guys, for watching this video, and thank you, Don, so much for coming on. And I hope you guys can find a little bit more on Oasis. Check them out on Twitter, on Telegram, and of course on their Medium as well. So thank you guys so much for watching, and thank you, Don, for coming here.
Great, thanks for having me. Thank you. It was a lot of fun. Thank you. Great.
Cheers. Yeah, it was really